Hey guys, in this video we are going to do a limiting reactant problem. In this problem we're given a reaction where we have barium nitrate reacting with sodium sulfate to form barium sulfate and sodium nitrate. The problem is telling us that we have 200 grams of barium nitrate and 100 grams of sodium sulfate. Our objective is to figure out, given a complete reaction, how much barium sulfate product we can form. Now, before doing anything, right, this is a very different setup than our traditional moles and stoichiometry problems. In this case, we have a fixed amount of both reactants, which means one of these reactants is going to be used up before the other. So before we can figure out how much product we're going to form, we need to first figure out how much product we can form if we use up all of the barium nitrate, and we need to figure out how much product we can form if we use up all of the sodium sulfate. Then we can compare the amount of barium sulfate that's formed under both of those hypothetical situations and essentially pick the smallest. So let's start off here. Let's start off by taking our 100 grams of sodium sulfate, right? And you take that 100 grams of sodium sulfate and figure out how much barium sulfate we can form if we assume full reaction. So just as we've seen before, if we are going to move between the amount of one reactant and another chemical compound in that balanced chemical reaction equation, essentially our product over here, we're going to be using our mole-to-mole conversion. However, we first need to convert into units of moles. So we're going to need to use the molar mass of sodium sulfate, which is given to us right here. So we're going to use the molar mass of sodium sulfate, which we are now told is 142.0 grams. And as I always recommend, I'm going to go ahead and write in not just the units, but what chemical compound that unit is associated with. So using the conversion factor, the molar mass, we're going to convert into moles of sodium sulfate. Then we're going to carry out a mole-to-mole conversion. We're now going to convert from moles of this reactant to moles of our barium sulfate product. So the product that we're after has a coefficient of 1. Right? Remember, there's always an implied 1 right here. So we can just write that 1 right here. And we are going to obviously be converting from units of sodium sulfate. Once again, the sodium sulfate here also has a stoichiometric coefficient of 1. So we really haven't changed the number at this point. We're basically multiplying by 1, but we are converting the unit. So it's important we write out that step. Now, at a final step, we want to determine how much product we are going to make, and we're going to go ahead and convert this amount. Right now we have moles of product that's formed. We're going to go ahead and convert it all the way over to grams of product by essentially multiplying now by the molar mass of sodium sulfate, which is 233.4 grams, barium sulfate, right? Grams barium sulfate for every 1 mole of barium sulfate. Now, if you carry out this sequence of conversions, you should arrive at an answer that is 164.4 grams of barium sulfate. Now, of course, that's not our final answer. We need to do this exact same thing over here, which we'll move through a little bit quicker. Right? We're going to now assume that we carry out the full reaction of all of our barium nitrate now. NO3,2. And to carry out this conversion, we're now going to use the molar mass of barium nitrate dividing through. We get 261.4 grams of barium nitrate for every 1 mole of barium nitrate. All right. Now we are in units of moles of barium nitrate. Now we can apply apply those stoichiometric coefficients, construct a mole-to-mole conversion factor. All right. Now we're going to be canceling out our moles of barium nitrate, and we want to end up in moles of product, barium sulfate. Okay. Just as we saw in the previous problem, our stoichiometric coefficients here, again, 1. So again, we've got 1-to-1 ratio, so we're not changing the numerical value. All we're doing is changing the units with both of those conversions. And then finally, we can convert over here to our mass of our final product using, just as we did previously, molar mass of our barium sulfate product. So 233.4 grams of barium sulfate for every 1 mole of barium sulfate. Plugging that in, you guys should come up with a number of about 178.9 grams barium sulfate. Now, just to recap, what we've found here is that if we hypothetically react all 100 grams of our first reactant, sodium sulfate, we will get about 165 grams of barium sulfate. If we react 200 grams of barium nitrate, we will get 178 or about 179 grams of barium sulfate. So the final answer for this problem is going to be the smaller of the two. Right? Because as soon as we have used up all 100 grams and formed about 165 grams of barium sulfate, there will be no more sodium sulfate left to carry on the reaction, and so the whole thing stops there, and then you will have some excess barium nitrate left over. So the final answer here is that the limiting reactant is going to be our sodium sulfate. Okay, and we will form 164.4 grams of barium sulfate by completely reacting all of our limiting reactant sodium sulfate.